Aha! Hi everyone and welcome to Dr. Jankila's lectures. Today's lecture is about standard deviation. So, standard deviation is simply how each value in a data set is different from the mean. So, what that means is basically how spread are the data sets from the mean. So how spread each data set is from the mean. And why is that important? Well, it's important because we want to know how is the data in a study different from the mean, trying to evaluate when it comes into determination of medication for a certain number of people. So if the mean majority of the people are really closer to the mean, means we can come up with a better conclusion. If they're dispersed really far from the mean, then maybe what works for the mean may not work for these that are far from the mean. So what determines the standard deviation? So what determines that is basically the data set, how far it is from the mean. So we have two options in this case. Option number one would be small standard deviation, and I'm just going to refer to the standard deviation with SD. Small standard deviation, which means in this case, basically what it means is that the data set, each value is close to the mean. And the second option in this case would be large standard deviation, which is basically the opposite of this, which means is that data set, so on average, the values are far from the mean. So that's basically what determines the standard deviation, how closer or far are the data sets from the mean. And we have two options, small or large standard deviation. So how do we calculate standard deviation? So the equation, and something that I would like to note in this equation is that we have n minus 1. So this standard deviation is basically for a sample. The reason I'm saying it's for a sample, it's because for a population to calculate the standard deviation, the difference, and the only difference would be the minus 1 over here. It would be only over n, and n would be the population itself. But because it's really hard to calculate the standard deviation for the entire population, we take a sample and we measure and calculate the standard deviation from the sample. So what minus 1 indicates is basically the population minus 1, which means it's a sample from the population. It's not the entire population. So that if you see an equation that is so similar to this, but it has only an n instead of n minus 1, no, that's for a population, and it's not really used in studies. Mostly you're going to be seeing this equation, which is n minus 1, which indicates it's a sample standard deviation calculation. So what does each of these components mean in here? So let's take, first of all, this sign over here means it's a sum. So this is basically the sum. And then x, let's make it into a better one. This is the mean. And we went over what the mean is and how to calculate that, which is basically the average of all values. So this is the mean. And then the x, it's the value itself of the data point. So each data point, so what this means over here, each data point subtracting from the mean square. Now, why do I have a square over there? Well, the reason why, it's because what if we have a data point, let's say 2. Let's take an example over here. Let's say I have a data point. So data point would be 2. And then the mean is -4. Or actually 4. And the minus is here. So 2 minus 4. So 2 is the data point. And 4 is the mean. So 2 minus 4 over here would be -2, right? So to prevent of having negative values, we have the square over there. So -2 squared is basically 4. So that's the purpose of having this square down there. So let's take an example to better understand how to calculate the standard deviation. So we have this example over here, and on purpose, I made the example really simple in terms of numbers, just to have a better understanding how to calculate the standard deviation. So we have a data set over here, which is 2, 4, 6, 2, and 6. So what do we need to do? Step number 1. Step number 1 would basically be calculating x, which is the point, the value point minus the mean. So first of all, let's take the mean. So what is the mean over here? So we said we're gonna add these up and then divide them over the number of values. So we have 1, 2, 3, 4, and 5. So numbers of values are 5. So the mean equal the sum of these over their values. So it's how many value point. So we have 1, 2, 3, 4, 5. And addition, let's add these together. So we have 4 and 6, that's 10. 2 plus 2 plus 6. And these here, another 10. So the total value, it's basically 10 plus 10, it's 20. And like I said, I made the number so easy just to understand how to calculate the standard deviation. So 20 over 5 is basically 4. So this is the mean right now. We have x. We have this right now. So this is what this means. Now, let's calculate this one on the top. So x minus the mean. So let's do this for each one of them. So this is going to be x minus the mean. And squared. So let's go with first data point. So we have 2 minus 4, which is the mean, squared. 2 minus 4 is minus 2. Squared, it's going to be 4. So this is first data point. Let's go to second, third, fourth, and then fifth. So we have over here 4 minus 4 squared. And the answer in this case would be 0. 4 minus 4 is 0. Squared doesn't really matter. Third data point is 6. 6 minus 4 squared. So 6 minus 4 is 2 squared. 2 multiplied by 2 is basically 4. So we have another 4 over here. The fourth data point is 2 minus 4 squared. And the answer in this case, it's going to be just like the first data point, which is another 4. The last data point is 6 minus 4 squared. And it's going to be just like the third data point, so it's going to be another 4. So now we have done this, which is this part. Now we need to have their sum. So what's their sum? So we have 4 plus 4 plus 4. So 4 plus 4 is 8 plus 4 is 12 plus 4. So we have 16. So now we have this part over here. Okay, so let me do this over here. So standard deviation, we have a square root. So the sum is 16. N is basically the number of data sets. So we have 1, 2, 3, 4, and 5. Minus 1, because it's a sample, it's not the entire population. Minus 1, so this is going to be 4. So basically what we have over here, this is, so basically what it is, it's 16 over 4. So 16 over 4, before taking the square root, is basically, if we divide 16 over 4, that's 4, and that's 1. So square root of 4 is basically 2. And this is the standard deviation. So what does this mean? We have a standard deviation of 2, which means is that we know that the mean is basically 4, right? So we know the mean, this is the mean, and it's 4. Which means that plus minus 2. The mean plus minus 2, which is the standard, so this is standard deviation. This one here, it's the mean. So what this tells us is that the mean is 4, and the value, how they're spread around the mean, it's plus 2, which would be 6, or minus 2, which would be 2. So that's what the standard deviation tells us in this case, is that the data sets are spread plus minus 2 around the mean. That's basically what it tells us, is how far each data set on average is far from the mean. So now we know, and like I said, I picked this number really just to make it easy. In reality, numbers are really different, and the higher the number, the better we can see it. The less the number we have and the high variation with number, we would end up having different standard deviation for the data set. So looking at this, we know that the mean is 4, which is in the middle, and the data set are spread plus 2 to the mean or minus 2 to the mean. So 2 to 6. So that's what this whole standard deviation calculation involves. Now, I did mention in the previous videos that we do have normal distribution sometimes in the studies. And in case of normal distribution where the mean is used, we basically looking at this over here, because it's normal distribution, which is really important to notice, because in normal distribution, we have the mean, median, and the mode. They're all equal. They're all having the same value. So looking at this, where does the standard deviation comes into play when we're having a normal distribution? So looking at this, basically, whenever we have normal distribution, 68% is basically within one standard deviation. So one SD mean one standard deviation. So 68% of the sample we're having is basically within one standard deviation from the mean, which means is that if the mean is over here, it's basically plus minus 34, because that's 68 divided by 2. So it's going to be plus over here 34 minus 34. So if the mean is here, plus 34 minus 34, that's one standard deviation. Within two standard deviation, we will have 95% of the sample. So 95%, so let's say we have a sample of 100 individual in this study. So which means 68 of these individual, they are going to be within one standard deviation if we have a normal distribution. If this is not a normal distribution, then it's not going to be the case. So remember, it's always in normal distribution and not in any other case. This is really important to notice. It's only in normal distribution these applies. So we said 68 individual are within one standard deviation. Now, within two standard deviation, I said we have 95% of the sample, which means 95 individual are within two standard deviation. which mean they are plus 47 or minus 47. So if the mean is here, if it's within 2 standard deviation, just like you see, the further we get from the mean, so the mean is here, right in the middle. The further we get from the mean from either side, we're going to include more people from that sample. Okay? And as we go further, all the way up to plus 47 or minus 47, that's going to be 2 standard deviation. And the last one is basically 3 standard deviation. In 3 standard deviation, what do we have? We have 49 on this side. So we're going to have 49 plus or minus 49 on this side to the left side, which means over here, 98 individual are included within 3rd standard deviation. Like I said, the further we go from the mean, the more individual we will be having in these standard deviations. So in normal distribution, as we go further all the way to the 3rd standard deviation, 98% or 98 individual, if we have a sample of 100, they're going to be included. So this is it for this video. If you have any question or comment, please leave them in the comments below. And as always, thank you for watching.